Hello and welcome to another episode of Java by Example, and we're going to continue with our invoice example, and today we're going to look at expanding our bit of product information here where we show each row of the invoice. And one of the first things I want to look into is to push all the numbers to the right, so we will right float or right align all the numbers to the right side of these columns, so they will be a bit easier to read, I guess. So let's get into the code here. So first off, we need a new public method where we could put text to the right or something, and then we put an X value and the Y value and string text. So that's pretty much it. And here we want to use the current font and figure out how large of a distance we need to move our current font in order to push it to the right. So to do that, it's required that we figure out how large or how wide the actual text are. And to do that, you need to take the font, and there's a function called get string width of the text. But if you see here, we actually ask in the font how large is this piece of text, and it's not the font size, or the font size isn't included in this call. And the documentation for this function is that it will give the result in the smallest increments of the EM square. So an EM square is something in the order of 1,000 points. So you draw a font in a rectangle which is, or a square that is thousands times thousands of points, so you can draw a really nice character over that. So that's actually how the character is stored. So this will give us a value which is somewhere between 0 and 1, which is 1,000th of this square. So if the text is 0.1, then it's 100 points in this square. And the EM square, the relation to the actual points that we are using in the PDF documents, is actually 1 to the 72 to an EM square, which means that on one EM square you have 72 regular printing points, and you have 1,000th points of drawing of this font. So we need to take this actual length of the text and multiply it by 1,000 and divide that value with 72, and actually also multiply that result by the actual font size to get the value that we are looking for. So this seems to be a bit of a weird calculation, but yeah, this is the way to figure out how large is the font against the actual canvas that we are drawing. So let's try this out. We save this to a float and say that this is the width of text, and then we need to take our x value and push it. So let's say that our new x value is equal to the width of the text. I think the x minus the width of the text, and that should be rounded as well. So math round, so we will get an integer value here, and I believe that math round actually gives us a floating value, so we need to do that as well. So this should be fine, I guess. So that should push the x value, and then we could do the regular this put text with this actual value and the y value and the text. So let's try this out. So let's keep all the numbers where they are. They will just be printed in the other direction, and when we change how we print them. And this could go really good, and it could get very bad as well. So let's try this out and see if we are in the ballpark or of a correct solution for this. So let's see here. Go back here, and we build our, package it up. Let's see if we can. We can't. We still have an IO exception. I guess it's in this here, yeah. So this still throws an IO exception, so we need to send that through, of course. And then we run this. No errors. So let's see whether... Oh, they disappeared. So that calculation wasn't correct. So let's figure this out then. And did I do this in the wrong order, perhaps? Yes, let's just first try to multiply these values and see how far off we are, or if we could actually use just the numbers. So how far off the math is here. That's pretty far off as well. Okay. Then we'll see what kind of values we get here. We start by printing out the x value, and then we print out the width of the text. And we could also take just a clean width of the font and see if we get any reasonable values. And I believe that these were printed in 8 points of a font, so we'll keep that in mind because that's the value that won't change. So build this up. Let's see here. So we get back something that is a really large number. So that's actually the full square width. So that's huge. So I guess that we first need to divide it by 1,000 instead of actually multiplying it. And then Yeah, so let's see here. We divide it by 1000 and turn this around. See what kind of results that we get then. Might be more of a reasonable amount. That's still a huge number. Yeah, let's try to figure this out. Math is hard, and especially when you have very weird math going on. So let's start with just saying that we want to divide it by 1000 and then multiply all of this with the font size. Start off there. Could be that easy. So that seems that we move it a more reasonable spacing, and they actually align. Okay. So we didn't have to take the actual EM count into account, because we are not talking about the full area, I guess. Interesting. And as we see, we don't get that much of a rounding error, so I think they are actually positioned quite well. And yeah, so this is the string width represented in the actual points. So we will get something that is in the EM square of 1000, and it was above 1000, so that's reasonable as well, because we are talking about the full text, and the full text is a few characters, so that's not that weird. So if we have just the letter A, then we might get 200 or something, but here we get 2000, and then we divide that down, so we get that into the actual amount of this square, and then multiply that by the font size to get the distance. So yeah, this works. And now let's try to move all our values to the end instead. So we have this rectangle here that we know ends up at 570. So let's draw this to the right of that and a few points in. So let's say 65. And if we move this from 10 to 65, that's 55. So let's move these 50 as well. Yeah, go to 60. So we'll see where we end up. And this should then move 50. So that's 42, right? The answer to everything and so on. Let's build this and see where we will end up. I think we will remove those messages as well. Yeah, not bad for a first try. And think we need might need to move the quantity a bit, a few pixels or something, but the rest I think could be where they are. Or perhaps we do it the other way around, that the unit price you'd move, let's say, 5 back, so it's not up against the line if we put the line after it. Could do. I think we will actually put the lines in and see how this will shape up then. So let's draw some more rows. I actually wanted to move all this stroking out, this fill work outside of this function, so we could actually fill the rectangles and make our descent without without actually having to draw the text as well. So let's do that. We move out to the invoice and we go here. We create a new function, public void print row background. That should be good. And then we will take all this information up here and put it down here. So that's good. Stop here. Then we just do this above here. Print background. And I think the reasonable way to do this is to actually have this this information moved inside of this here. So if we don't think we need that odd value here any longer, so that will be done by the actual row printer. And then we could push it down here. So here we have that value. We say that we want to start at row. First we need the contents. We will start at row Y and we want to print 10 rows. Let's start there. And 4. Let's do our 10 rows here. Rows. I can call it number of rows. And increment it. And we'll set this odd value from the start. And just fill or stroke. So here we will add a rectangle or fill and stroke. And then we will do this change as well. So this will give us pretty much the same function that we had before, except we will get the int row y here and the int number of rows as well. So we have those values inside of this function. But I want to change this up a bit. So I will change this to just fill. And instead of adding a rect, I want to use a function called move_to, and that's a function that actually moves to a point that I defined, and then you could draw a line from that point to another point. And in our case, we want to move to the point of row Y and 70. So 70 pixels row Y. And then we want to draw a line. So content line 2. In this case, we want to draw the line a bit down. So this should be 70 row Y minus 20, because that's the 20 pixels that we want to draw. And then we want to move and do the same at 570. Let's put the 5 before that. And let's do, I don't believe we need to stroke those, do we? Guess we might not. Let's try it. And let's say that we do this fill on odd rows now. And so let's see. We want to draw the lines on the side. Yeah, that should be good. And when we are done with this, we also want to move to 70 at row Y, and then go to 570 on row Y and draw the line at the bottom as well. So this might be the right. Did I remove the printing of the text here? I didn't, so let's remove this extra filler text, because that's working as intended now. Let's build it and look at it. Okay, so we will get, we got the actual filled rows, so that's good, but we didn't get our lines. So either we want to draw the lines after we actually get all the areas, because those could print above our lines. So let's try that first. And if not, we are probably required to do the stroking as well. So let's move this down here. And this could be at row Y minus 1, so we get it down 1 pixel more. So let's try that. Nope. So I guess we need to stroke these lines as well. And I wonder, I probably need to stroke. Do I need to stroke after each line or after each? Let's try it. We might want one more stroke in there. Nope. Didn't we set a... Yeah, we didn't set a stroke color. That we want to as well, of course. We want this as well, or else we won't get any color on the stroke, and that's no fun. Look at that. Oh, this looks much better. Except that we see here that we actually get the lines underneath our filled rectangle. So to do this easily, I believe we remove the strokes again, and then we want these to move in a bit. So we say that we have these inside there, and then I believe that we want to draw these up again. Let's try that. Let's see if we get the required results. Let's see here. Let's try that out. That wasn't the right way to go. Of course not. Strange. Should we move it up? Move it up. This should be right. It seems really weird because we have the other boxes we draw from beneath. So why shouldn't we draw these from beneath? Okay, so we want the strokes as well. Stroke. That should still be in there. Those are still required. So first you actually define where your lines want to go, and then you stroke them. And so let's look at the result. Now we have moved in a bit, but because we moved in one row, we actually need to move in two on the other side, because yeah, 1 pixel in on from one side means 2 pixels in the width. So that was to be expected, and we try to do pluses here as well. Now that we actually get a value. So the boxes are from beneath, but the values aren't, or the lines aren't. So now we get the line correct. That's good. And I guess if we want, we could move the last line requires to, why isn't it connecting over there? Is it because I pushed it 1 pixel down? Yeah, so we need that extra pixel there. So we pushed it down 1 in the y-axis. So we could try this. Still seems a bit weird. All these values seems a little bit off. Shouldn't be required. So now they are almost connecting down there, but not really. Might be that it draws 1 pixel above, so then we don't need the actual movement of 1 pixel. So now we have a box. That's good. But I want to move all of this content down 1. So let's start at 499, because the line before it was at 500. So we want to start a bit further down. And let's say that, let's see here where we are. We still have a bit to go on this document, so I think we could go a bit further and say 16 lines. Might be a reasonable amount of lines for this document. And let's look at this. Yeah, so now we should have some area, as you see down here, to put the summation, which I don't think should be this much of information. Should be less information down here. And then we get a box for notes. But I think this looks good. And because of the space between quantity and price and so on, I think it looks better without the lines. I don't think those are needed to make this readable. Yeah, so I think we're done with the actual box now, with the product lines. So next time I think we should look into the summation box and the notes. And yeah, I really hope that you learned something from this pixel hunting today. And if you like this kind of content, and if you learned something, please give this video a like. If you have any suggestions how we could do this better, or if you want to try it out yourself, please go to the GitHub page, and yeah, please comment. Give me more information about how you work with these kind of issues, and how you would solve this. And subscribe if you want to see the rest of this series or other Java examples. And I really hope to see you in the next video.